These are standard results for summations to show that for all positive integers n, this summation is what's shown on the right. Let's do it. So, summation from r equals 1 to n of r squared, r plus 1. Well, first thing I'm going to do is expand the brackets, give me r cubed plus r squared, and then separate it into these two separate summations. I'm also going to just write the summation sign. I'm not going to write r equals 1 every single time. Now, the sum of r cubed it's actually the square of the sum of r, which is a half n plus 1. So this becomes a quarter n squared n plus 1 squared. And then the sum of r squared is 1/6 n plus 1 times 2n plus 1. Let's try that one more time. Okay, so I can apply that here. I'm going to get a quarter n squared n plus 1 squared plus 1/6 n. Now you can have half an eye on the answer, but actually, like, good practice is going to be anyway to factorize out as much as we can. We can factorize out an n and an n plus 1. Let's factorize out 1/12 as well while we're at it. So 1/12 n plus 1. And then I'll be left with 3 in this case to get me back to a quarter. I'm dividing 1/4 by 1/12 essentially. And then n plus 1. And for the other one, I'm going to get 2 lots of 2n plus 1. All right, so we've just then got to simplify that and yeah, factorize it to n plus 2 times an plus b. Let's just keep going. So this is then going to be 1/12 n plus 1 multiplied by 3n squared plus 3n plus 4n, so that's going to be 7n plus 2. And then if it's going to factorize, well, we're looking for an n plus 2 in the answer, so then I'd need a 3n and I'd need a 1. Just check that that gives us a 7n. It does, we get 6n, and then we're sorted. Hence show that for all positive integers k, the summation on the left is this. Okay, well, note, we're now no longer summing from 1 to n. It's actually r equals k plus 1 to 3k. So that summation is going to equal the summation from 1 to 3k minus the summation from 1 to k. So what we can do is take our answer to part A and just replace n by 3k in the first instance for the first term and k for the second one. So this will give me 1 over 12 times 3k plus 1, 3k plus 2, then 9k plus 1. And I'm minusing 1/12 k plus 1, k plus 2, 3k plus 1. Again, keep an eye on the answer, but in any case, we can see there's a common factor of 1/12, there's a common factor of k, and there's a common factor of 3k plus 1. So then I'll be left with 3 times 3k plus 2 times 9k plus 1 minus, then it would be k plus 1 times k plus 2. Just going to bring this down. Oh, I'm going to get a quadratic. It doesn't really tell me much, does it, actually, if I bring this down? Let's just keep going. So I might now just focus on this bit. I'm going to get 9k plus 6 times that first bracket by 3, 9k plus 1 minus, let me expand the bracket here, k squared plus 3k plus 2 gives me 81k squared plus 9k plus 56k. That's going to be 63k plus 6 minus k squared minus 3k minus 2, which gives me 80k squared plus 60k plus 4. Now, actually, in the final, it is worth bringing this down. In the final answer, they've taken out a factor of a third, so I can see I need to also take out a 4, and we can do that here. This is 4 lots of 20k squared plus 15k plus 1, and hence my final answer is going to be that it's 1/3, because I'm doing 4 times 1 over 12, k, 3k plus 1, and then 20k squared plus 15k plus 1. Nicely done. And the final part, or has to hence use an algebra, making our method clear, determine the value k for which this is true. Now we've already worked out this term, apart from the 25, so I can just times my answer by 25 and set it equal to the right-hand side. Let's do it. Remember, we're solving for k being a positive integer. It's inside this summation notation, it has to be. So I have 25 over 3 times k, 3k plus 1, 20k squared plus 15k plus 1 equal to 192k cubed bk plus 1. And just cancel them out and cancel that k out with this 3, giving me a squared. So 25 times 20k squared plus 15k plus 1 is going to equal 3 times 192, which is 576k squared. This is a quadratic. Multiply this out, 500k squared plus 375k plus 25 equals 576k squared. Then minus all of the left from both sides, giving us 76k squared minus 375k minus 25 equals 0. Don't try and factorize this. It will. It has to. It has to be a positive integer solution. But just put it in your calculator, which gives k equals minus 5 over 76, which we're going to reject. First of all, it's negative. Secondly, it's a fraction, or 5, which is what we're after. And that's our solution. Nice question. Like it.